All right, ladies and gentlemen, welcome back. We are in Chapter 6. This is Section 6-1. This is video number 3. Okay, we left off, I believe we were going to start talking about example 6-1. Examples are great. They really help explain everything, but they only help you if you follow my advice and if you write them out in detail, adding any additional information that you need, some sort of an explanation about what's going on in your own words so that you can make sure that you understand it. I can guarantee you that the best way to learn something is to try to teach it to somebody else. And if you try to teach it to yourself by writing it out, you're going to understand the material. All right, so example 6.1 is find the area under the standard normal distribution curve. Now, if you've read ahead, if you have read a little bit further along in the book, very shortly he starts talking about this as being a probability distribution rather than just being a normal distribution. Just to give you a heads up, that's what the whole point of this is that all of these distribution curves, we can consider them to be a probability distribution. All right, so he talks about find the area under the standard normal distribution curve to the left of z equals 1.73. So let me it's in the back of your book. This is the PDF version of the textbook that I sent out to some of you. It's the 9th edition, so it's a slightly older edition, but I believe the tables are exactly the same. So back there in the back of the book is Table E, the standard normal distribution. And as I mentioned to you, at the bottom here, it's got the little cartoon to help remind you. Now there's 2 pages of this. Here's the second page. Here's a different cartoon. What's the difference? The difference is that these z values here on this page are positive. So that's why it's here as a positive number. So let's just say that 2.3, boom, there it is. Go back up here. On this page, it looks like the z is to the left of 0. Well, that makes sense. Here it is, negative 1.8. So whether it's the positive or the negative, the concept is exactly the same. This is a table. Here's the z values. Now the way the table works is, let's say let's just look at the example we have here. Give me 1 second. Okay, find the area under the standard normal distribution to the left of, and it's 1.73. Okay, so 1.73, okay, z value 1.7. Well, we don't want 1.7, we want 1.73. Well, how do we get the 1.73? Well, it's this row right here, and you got to look up here. So 1.70 is in this column. 1.71, you see what's going on here? You just add this to the 1.7. So 1.71 is this, 1.73 or 1.72, excuse me, is this, 1.73 is this, and so forth. And now I've forgotten what we're looking for. We're looking for, all right, so the example here is find the area to the left of 1.73. So here's 1.73, it's the area to the left. But what is this area? Well, we get that from the table. Here's the table. 1.7, and then we go over here to right there, 1.73. It's this guy right there, 0.9582. So that's the way all of these, this is the way this table works. All of these numbers in the middle, in here, give us the area to the left of that particular z value. So 1.73 is right there, 0.9582. So what it's telling you is that 0.9582 of the area is to the left of that particular z value. This cartoon down here is just to remind us of what it is that we're looking at. Okay, so that's what he has right here. 0.9582, and that's exactly what we had before. All right, so that illustrates, how do we use this table here? Now, all of these are going to be basically the same idea. It's very important, though, that you understand that this concept is that it's the area under the curve to the left of any particular z value that you are interested in. Okay, so the picture at the bottom of the curve, picture at the bottom of the table here, that reminds you of that. All right, look at another one. Area under the curve, under the standard normal distribution, to the right of negative 1.24. Okay, all right, so we want this area to the right. Well, this table does not give us the area to the right. It gives us the area to the left. Okay, oops. Okay, it gives us this area here to the left, but that's okay, you know, because we're considering it to be areas. It's very simple for us to figure this out. Sorry, it's not as easy as it looks to bounce back and forth here. Okay, so we want this area here, negative 1.24. Maybe I'll do it this way. I'll move it back and forth here. Okay. All right, so negative 1.24. We go over here, negative 1.24. Gosh, it's hard to do this on the screen. You know, folks, I think you're going to just have to be looking in your book here. I'm kind of bouncing all around. Negative 1.24 is going to be right here. Okay, it's 0.1075. 0.1075, which is exactly what he has right here, 0.1075. Well, that's the area to the left. That's the area to the left. That's what you get from this table here. Well, that's cool. If this area to the left is precisely equal to 0.1075, that's another way of saying it's 10.75%. Well, the area to the right is going to be 100% subtract 10.75%, or you can say it's 1.000 subtract 0.1075. I hope you see what's going on here. You're finding this area here and you're subtracting it from the entire area. It's the complement. So it's 0.8925 is this area here. So 89.25% of the area under the standard normal distribution curve is to the right of this guy right here, the negative 124. Okay, so the same exact concept applies for this one. Example 6.3, we want to find the area between 1.62 and negative 1.35. Well, that's perfectly fine. You just find the area to the left of 1.62. You find the area to the left of negative 1.35. You subtract, and that gives you the area that's left over. So here's a perfect example of why you should be writing these out. If you write these out and you draw the little cartoons, this is gonna make a lot more sense to you, I promise you. Okay. All right, so that takes care of that example here. So now in this section here, the author is talking about how the normal distribution curve can be considered as a probability distribution curve for normally distributed variables. And so many variables are normally distributed. It makes it a very useful concept here. Okay. All right. So he talks about it being a continuous distribution. I think we've discussed that at length. Okay. All right. So what he's talking about here is that, okay, if you're going to be talking about probabilities, you're talking about probabilities between certain z values. So like if you wanted to know what's the probability of being between here and here, well, it's the same as this area. The probability of being greater than negative 1.24 is going to be this area. The probability of less than negative 1.24 is this area. So all these areas can correspond to probabilities as well. So that's what he's talking about here. Now he makes a very good point here, and I've brought this up myself, that in a continuous distribution, this is where I'm reading, the probability of any exact z value is 0, because the area would be represented by a vertical line. There's no area in a line. A line in theory is 0 width, so there's no area underneath there. So if someone says, well, this is the probability of this exact value, you've got to be very cautious. That's not really what it means. It's always going to be an area is the only thing that makes sense when it comes to probabilities. And that's really not a big problem. We'll see here in a little bit how we can deal with that. It's not a problem. It's just the way it works. Okay, so he says find the probability for each. So we want to know the probability for z, or z score or z value, whatever you want to call it, being between 0 and 2.53. Well, here's 0, here's 2.53. So what you do is you go to 2.53 in that table, which I've still got here. 2.53, 2.50123 is 99 or 0.9943. 0.9943. That's the area. Okay, that's this area to the left of 2.53. That's the entire area. But we don't want the entire area. We want it only from 2.53 to 0. So we've got to subtract out the area that's to the left of the 0. So to the left of 0 is a certain amount of area. To the left of 2.53 is a certain amount of area. You subtract, and that tells you how much is left over. Now, do you believe me when I say that there's area to the left of 0? Well, why not? Why wouldn't you believe me? It's right here. To the left of 0 is 0.5, 50%. 50% is to the left of 0. But you should have known that even without looking at the table, because the normal distribution is symmetric and the mu is 0. So half is to the left, half is to the right. Okay, so all I can tell you, ladies and gentlemen, is these examples are very important, and if you write them out and if you draw the little cartoons, they're going to help you really understand this whole concept. And we're going to use these cartoons and these tables for the rest of the term. So you just got to learn what these mean. It's just absolutely essential. Okay. All right. So now here's what he's saying here now. All right. Sometimes one must find a specific z-value for a given area under the normal distribution curve, okay? So you have to kind of work backwards, okay, using that table. So find a z-value such that the area under the standard normal curve between 0 and the z-value is this amount. So between here and here is 0.2123. Okay, so what we're really looking, since we're going from 0 to z, and I just told you a few minutes ago, every z value, the area is to the left, right? So if we want this area down here to have, hold on one second. Okay, we want this area right here between 0 and the z value. We're going to find the z value. We want that to be 0.2123. Well, we need to find the z value that has to the left of that z value, not 0.2123, but it has to have 0.5 added to 0.2123. That's what he's saying right here. We need to add the 0.5 to the given area to get this cumulative area of 0.7123. So you look it up in the table and you find what the values are. Okay, so to get 0.7123 on that table is 0.5. You come over here and you find it. How did we find it? You just look. There's no magic to it whatsoever. You look at the table and you know that it's going to be a positive number, so you kind of look along here. You see, the areas are getting bigger as you go along, right? As you go further to the right, as the z values get bigger, the area gets bigger. So you just kind of look up here until you get close. 0.65, 0.65, 0.68, etc. Here it is, 0.7123. There it is. 0.56 is the z value that gives you a 71.23%. Now, sometimes it drives people crazy that we're bouncing back and forth between percentages and decimals, but that makes sense, right? I mean, we do that all the time. Sometimes we talk about probabilities, and sometimes we talk about actual numbers. Sometimes the probabilities are easier to express in terms of percentages. Sometimes we express them in terms of decimals. That's okay. We don't have any problem with that. Okay, so then take a look here. This section talks about what do you do to get the closest value, okay? All right, and he gives an example of a watch. I'm going to let you read that for yourself. Okay, that's the end of this section. This is the last video of section 6.1.